Okay, simplifying with rational expressions. You don't have the radical, so you can just rock and roll from here. You don't have to rewrite it. So the base we have is x, and then for the exponents we have to take the 2/3 from the inside times the -3. So 2/3 times -3 is -2. Okay, now we need to use this second line because we have a negative exponent. So that x has to switch positions to the bottom, so it becomes a +2. Now you come over here, whole exponent's all you got, okay? So you just align that. So obviously we don't need to check our sheet because that's just a 2. There's no bottom number with it. Okay, now you have an exponent on bottom. Is it whole or is it a fraction exponent? Meaning, is it a whole exponent or is it a rational exponent? It's a whole, so we don't need to mess around here. Okay, and then that does not have a denominator. It's just a whole number. So since it's just a whole number, we just bring it down. We don't make a radical. And you can't simplify it, but you do at the end need to put a 1 over it. So it's 1 over x to the power of 2. Okay, my next problem, we have a 5 times, and then a base x to the 2/3 power in parentheses with a negative first power outside of it. So stick to the game plan here. There's some things you don't have to do a lot on, but you got 5 times x. So 5's to the 1, but we just keep it to the 1 because it's outside. Then I take 2/3 times -1, which is -2/3. Okay, so that stays in its position, but the x has to change positions to the bottom so that we have a +2/3 power. Okay, now on top you have a whole exponent, 5 to the first, so it's not a fraction. Bottom we have our fraction, 2 to the thirds. Now over here you want to, if you have a fractional exponent, you want to circle the bottom. Okay. Now is there any way that you look up 3 and x is there? No, it's not. Okay, so I can't get rid of it right there. So now if I come down here, I have to ask myself a question. The bottom exponent, is it a fraction or a whole? It's a fraction, so you need to put RAT. I don't care about the top. The top can be a fraction, but the bottom is a fraction. You have to rationalize it. So remember how to do this. You copy your top down. Then you write x to the 2/3 power. Now you need to times by another x with a 3 on bottom, and you take 3 minus 2 to figure out the top. 3 minus 2 is 1. Now you also have to remember to bring that to the top, x to the 1/3 power. Okay, so this becomes x to the full first power because a 2/3 plus a 1/3 is a full first. Now you have the fraction out of the bottom. Now you come over here and set up your radical if you still have a fraction, which we do. Okay, so 5 to the first and x to the first are just pulled over. But when it comes time to look at that 1/3, we make a radical of a 3. And then inside we put x to the first power. Okay, now simplify. 5 to the first is 5, and then a radical 3, x to the first. You could leave it as x to the first or just put x, it doesn't matter. Then x to the first on bottom, you can put x or x to the first. Next problem, underline the expression, because we have it in exponent form, which is what we want, so I don't need to rewrite it to the side. So first thing I do is I take 2/3 times -12. It's -8. Then on the y, I take the -1/6 times the -12. It's 2. Okay, this one has to switch positions. Becomes +8, that one stays in position. So now we're going to obviously start utilizing the second line. So circle your exponents, they're both whole. So I don't need to look at my radical sheet. Okay, they're both whole, there's no fraction, so there's no bottom. Now the bottom exponent, you have it, but it's a whole number, so I don't need to rationalize it. Okay, then these are both whole, so I don't need to make a radical for it. And then simplify, you can't simplify y to the second, you can't simplify x to the 8th, that's the answer. Okay, next problem. We have a division line. On top we have x to the negative 2/3 power. On bottom y to the negative 1/3 power, and all in a parentheses with a 15th outside of it. So you got x and y. So a negative 2/3 times a 15 is negative 10. Then a negative 1/3 times a 15 is a negative 5. Well, they both have to switch positions. So this guy goes to the bottom where it becomes a positive 10. This guy, he has to switch too, so he goes to the top so that he becomes a positive 5. Okay, then the exponents are both whole. So you don't need to use your radical sheet yet. Okay, we're not going to have to anyway because the fractions are gone. We don't have any. Okay, now I have a bottom exponent, but it's a whole. Okay, so I'll start putting the word whole. Whole means you don't need this. Okay. Then put your whole exponents. You don't have any fractional exponents, so that's why we don't need to make the radical. Then y to the 5th would stay the same, and then x to the 10th would stay the same. Okay, next one, y to the 1/2 power times y to the 3/10 power. So you have a base y, and since you have two of them, that means we add. We just take 1/2 plus 3/10. Okay, 4/5. That's positive, so it stays in the same position. Okay. Okay, now the only exponent you have is a fraction, so when you bring that over, you want to circle the bottom. Now, if I look at my 5 list, y is not on here. Okay, so it stays. Now, you don't have anything on the bottom. It doesn't matter what you have on top when you're deciding what to do here. You don't even have a base on the bottom, so don't do it. Okay, now here's to make the radical if you need to. We do need to because we still have that 5. So I make a radical of a 5, and inside we put y to the 4th power. Since it's to the 4th power, you can't just put y. Okay, so we have a radical of a 5, and then the y to the 4th, can't really simplify. Okay, x to the 3/5 power over x to the 3/10 power. So you got x and x on bottom, 3/5 and a 3/10. Now if you're not good at comparing fractions, just cross out the bottom one. Okay. If it's negative, you'll just switch its position anyway. So we're going to take a 3/5 minus a 3/10. 3/10. Yep, okay, 3/10. Okay, that's positive, so it stays in the same position. Okay, now it's a fraction, so bring it over. But when you're bringing it here, just circle the 10. Now, I don't even have a list for 10s, and if I did, x sure wouldn't be on it, okay? So it stays, okay? You can't slash it out. Okay, then do you even have a base on the bottom? No, you don't, so you don't have to rationalize. Okay, so then you have your base with the fraction exponents, so you make a 10th root, and inside you put x to the 3rd. And then you have your 10th root. Then you just have the variable with its power, nothing you simplify. Okay, next problem. Base is x and y on top and bottom. So x times y, x times y. We don't need to multiply, we just have a 2/3 and a negative 1/4. Then a 1/2 and a negative 1/2. Okay. If you're not sure what's bigger, just cross out the bottom. If it ends up negative, that's fine. We'll just move it out of position anyway. Okay, 1/6. That's your power on x. Then remember, when you minus this one, you got to minus negative 1/2. You can't just minus. It goes to plus plus, but here I'll punch it in. That's 1/4. Okay, they both stay in position because they're both positives. and they're both fractions. Okay, we don't have any whole ones. X to the 1/6. Remember, you just circle the bottom when you're over here. Now, if I look at my 6, X isn't there. And if I look at my 4s, Y isn't there. So I can't slash them out the quick way. Okay, do you have to rationalize? Do you even have a base on the bottom? No. Okay, so you do the RAT when it's on a fraction on bottom. Okay, if I don't have the bottom, cross that out automatically. Now, write it into radical form because you still have bottoms. Okay. So we make a root with a 6, and inside you put x to the first. Then you have to make another root with a 4, and inside you put y to the first. So your radical, 6th, and a 4th, and you just have the variables, so it'd be x, y. The 6th root of x times the 4th root of y. Okay, base is on top. You got 16 times x, and then on bottom you got 81 times y. So 1 times 1/2 is 1/2. 14 times 1/2 is 7 whole. On 81, 1 times 1/2 is 1/2, and then 18 times 1/2 is 9 whole. Okay, you can't cancel anything because you don't have 81 on top, you don't have y on top, so no canceling. Okay, that's when you do what we did here, cross them out. Okay, and everything stays in position because it's all positive exponents. Okay, now circle your fraction exponents and your whole. The wholes need to come first. X to the 7th, y to the 9th. Then you write your fractions, and when you write them, you need to be circling the bottom. Now look at your 2's. Pretty good possibility we can get rid of those right now the quick way. So I'm on the 2's. They're both 2's. So here's 2, 16's there, it's 4. And now we have 4 to the full first power. Okay, so now that's no longer a fraction. Look at your 2, and I think 81's there 2. That would be 9. So now we have 9 to the first power. Okay, the first because that was what was on top. Okay, now look at your bottom bases. That has a whole exponent, so that's good. And now the base is 9. It has a whole exponent there too, so we do not need to rationalize. Okay, now write down your wholes. I think that's all you got is wholes. So x to the 7th, 4 to the 1st. So since they're all wholes, I don't need to make a radical. Y to the 9th, whole, W-H-O-L-E. And then 9 to the 1st. No radical. So that's a 4, that's a 9. And the variables stay the same. Okay, 3 more. So again, those are my bases. So on top you got 8 times x. On bottom you have 27 times y. So 8's to the 1. 1 times 1/3 is 1/3, a fraction. And then 6 times 1/3 actually gives me 2 whole. 1 times 1/3 is 1/3. And then 9 times 1/3 is 3. None of them need to, you can't cancel because you don't have a base 27 on top or a base y on top. They all stay in their position though because all of them are positive. If any of the exponents are negative, they need to switch positions, top, bottom, bottom to top. Okay, now circle your whole powers, put those first, and then circle the fractions, times 8 times 27. 1/3, circle that 3, 1/3, circle that 3. Now look at your root list and see if 8's on the cubed root. You're on 3's now. 8's here, it's 2. So this now is able to become 2 to the whole first power. 27 and 3. This is how you, 27's there too, so now that becomes 3 to the full first power. Now we have a base on bottom of y, but it has a whole exponent, so we don't need to rationalize. And then 3 now has a whole first of 1, so that's a whole as well, because that's now 3 to the first. Okay. So Nothing doing there. Now, write down all your whole exponents. 2 x to the 2 times 2 to the 1, and then y to the third times 3 to the 1. And since there are no bottoms, okay, we don't have any fractions, we don't need to make a radical. Okay. Then 2 to the first is 2, x to the second, 3 to the first is 3, times y to the third. Okay, works like game plan will work if you use it. Okay, base 125 to the negative 2/3 power. So 125 is the only base. 1 times a negative 2/3 would be a negative 2/3, but that has to switch positions so that its exponent can become positive. So that's the only exponent we got. It's a fraction, okay? Now this problem is why you need to look to see if, before you worry about whether it's a fraction, see if you can get rid of it on the 3 list. Here's my 3 list, and 125 is here, so it's now a 5 to the whole second power. So now I have a base 5, but it's to a whole power, so whole. That's why you got to look at the list at that point before you realize, before you decide. Now you don't have to use this, okay? And I write down my whole where it's at, and I don't have any fractions that I need to make into radicals. Then 5 to the second power is 25. Please put a 1 over it if the top ends up empty, because it's 1/25. Okay, last problem. So you've got 8 times x times y, and then 27 times x times y. So 8 to the 1, so 1 times 2/3 is 2/3, that's a fraction. 9 times 2/3 is 6. 3 times 2/3 is 2. Then in the 27, 1 times 2/3 is 2/3. And then 2 times 2/3 is not a whole, it's going to be a whole and a rational exponent, 1 1/3. And then 12 times 2/3 is 8 whole. Now you can do some canceling at this point. Not with 27, but with x you can. You can get that x out of there, minus 1 1/3. So 6 minus 1 ABC1 ABC3 is 4 2/3. And then the y, y2, y8, we should probably get rid of the 2 because it's smaller. And 8 minus 2 is 6. Okay, so all these powers, the 8 has a positive power, it stays in position. The x has a positive power, 4 2/3, it stays in position. The 27 stays in position, and then the y stays in position. Now let's separate the fractions from the wholes. Okay, so for wholes I got 4 and 6, so I bring over x to the 4th, y to the 6th. Now put your 8 on top. You got a 2/3 power on the base 8, and you also have a 2/3 power on the base x. Then on bottom you have a 2/3 power on the base 27. Now you want to circle those bottoms. Okay. Now look at your 3 list and see if 8 is on there. It is. It's 2. So now that becomes a full 2, a 2 to the full second power. Okay. And then 3, you know x isn't going to be there, so that'll have to stay. Then 27, that's there, that equals 3. So now it's 3 to the full second power. Okay. Now look at your bottom base is a y, and now we have a 3. Okay. So that's a whole, y to the 6th. That's a whole, it's 3 to the second. So we do not need to mess around with rationalizing. Okay. Alright, now write your wholes down, x to the 4th on top. Now the other one's still a fraction, so we make a cubed root out of it. And inside, put x to the 2nd. On bottom, you have y to the whole 6th power, and then 3 to the full 2nd power. Oh, sorry, the 2 to the, I forgot about the 2 to the 2nd. That's on me, okay. X to the 4th, 2 to the 2nd. Okay, I forgot to put the 2 to the 2nd. So, because we still had that. So 2 to the second is 4. X to the fourth would remain that. Then in the radical of the cubed root, we just have the variable with its power. Now on bottom, you got 3 to the second, that's 9, but then the y to the 6th would stay the same, and that's simple, because that's simplified, okay?